When you're working with formulas, particularly in science, you sometimes want to rearrange the formula so that a certain variable is isolated. So this is where your solving equation skills comes into practice again. Let's just work with a couple of formulas here. Here's one that's probably familiar looking. This is the perimeter formula for a rectangle. The perimeter equals 2 lengths plus 2 widths. And this formula is good to go. If you happen to know what the length is and the width is, you could simply plug in the L and the W and out would pop the perimeter. But let's suppose you had the perimeter and the width and you wanted to find the length. Well, you could certainly plug in the numbers that you know and then solve for the variable that's left over. But I want to work today just with the equation the way it is. So what we're going to do here is work towards solving for L by leaving W and P the way they are. And the key to doing this is that if you're going to solve for a given variable, you want to think of the other variables as numbers. So you just want to think of this chunk as a number and this chunk as a number and ask yourself, what would I do if those things were numbers and I was just solving for L, sort of the only variable? Well, what you would do is you'd say, if I want to get the L part by itself, then I have to get rid of the part that's added to that over here, the 2W. So I'm going to have to subtract 2W on both sides. Okay? Thinking of the 2W just as a number. All right, well, P minus 2W, since they're not like terms, the best I can do is leave it like that. Equals, this is 0, adding, and so that's 2L. And then to get my L alone, I need to divide both sides by 2. And so I'm just going to put my L on the left because I like it there. So L is equal to P minus 2W divided by 2. And there's my formula, the same formula as we had above, but rearranged with a different variable isolated. So if I knew my perimeter and I knew my width, I could just plug those into the formula quickly and out would pop my length already isolated. Here's another familiar looking formula, the area of a circle. Area equals pi r squared. And what we want to do is isolate the formula for r. In other words, we want to think of the other variable, in this case the a, as just a number. So that sum number equals pi, which is a number, times r squared. Alright, so to get the r part by itself, the r squared, I'm going to have to divide both sides by pi, because the pi is multiplied to the r squared, and so a over pi equals radius squared. My radius has been squared, and I want to get it reversed to a regular radius. So the inverse of squaring is square rooting, so I'm going to square root both sides. And so my radius is the square root of a divided by pi. Same formula, looks different as the original. If I knew my area of my circle, I could simply pop it in here, divide by pi, press equals, and then the square root button, and out would pop the radius. Alright, let's do one more example. Here's some kind of random formula, ax divided by b minus c equals L. And what I want to do is solve for x. Alright, so again, my strategy that I like is to think of everything else other than the x as a number. You can imagine 2/3 x minus 7 equals 1. If you were solving that equation, what's the first thing you would do? Well, I'm hoping that you might want to eliminate the fraction first. It's not necessary, but it's recommended. So because I have a common denominator of b here, I'm going to multiply both sides of the equation by b. And so that's going to be b times ax over b minus b times c equals L times b. Alright, and so I've got some fraction work going on here. This is b over 1. I can cross reduce. B goes into b once, and so I have on that term ax minus bc equals lb or bl, whichever you want. Doesn't matter. Okay? Alright, so I've eliminated the fractions in my question. And so there's the x component. I want to get rid of this component. So to neutralize minus BC, we're going to have to add BC to both sides. BC is a chunk multiplied together, so we can't bust it apart. These two things add to 0. And so on the left I have AX. And on the right I have BL plus BC, which are not like terms, so they cannot be combined. And then on the left we have a times x, so to get rid of the a multiplied onto the x, we're going to have to divide both sides by a. And therefore x turns out to be b times L plus b times c, all divided by a. This formula is equivalent to my starting formula.